Okay, so, yeah. We're going to plot these points first, right? So we've got the point -1, 0. We've got the point 0, 1, and 1, 0. When in doubt, unplug, like restart, right? Okay, yeah. Hey. All right, so we have our 3 points. We've got those. We know that they are definitely right, so I'm done with that. One thing that I do want to talk about, and this might help you, sometimes when you're sketching these graphs, it's helpful to have the vertical and horizontal asymptotes that are intended, if there are any. So the way we identify vertical and horizontal asymptotes is by looking at these functions. If you are given a statement that says the limit as x approaches a, meaning some given x value, either from the left or the right or overall, is equal to positive or negative infinity, this means you have a vertical asymptote at that given a value. Okay? If you are given a statement that says the limit as x approaches positive or negative infinity, so this is what we were just talking about, meaning your x values are going to increase or decrease without bound in either direction, is equal to some number, then you have a horizontal asymptote. Okay, so I would look for those second. Plot your points first, then look for horizontal and vertical asymptotes. Okay, so in this case, it appears as though we only have vertical asymptotes, and we have 2 of them. So here it says the limit as x approaches -1 from the right, okay, is equal to positive infinity. So that means at -1, we will have a vertical asymptote. So I'm going to put that on here. Okay, now, I got the question yesterday, is it possible to have a point when you have a vertical asymptote? Yeah, it is. Okay, typically, those points will fall on the x-axis, but it doesn't always happen. Okay, in this case, on the x-axis. Okay, then here it says the limit as x approaches +1 from the right is negative infinity. That means at +1, I also have a vertical asymptote. Okay, so I put the asymptotes on here. So I have vertical asymptote, vertical asymptote. Okay, so now we actually have to sketch the graph. And this is just me, you can do it however you want. I like to work from left to right. So what is happening to the graph from the left to the right? So any value that's going to be less than or equal to -1. So I'm looking at any statement that in this case that has a -1. So here we're looking at the limit as x approaches -1 from the left, meaning I'm coming from this side. It's saying that the value is equal to 0, meaning whatever my graph looks like, a line, a curve, anything, whatever happens, it needs to approach or go to 0 from the left. So here I am at 0, right? It does not matter what your graph looks like. I could make it look like this. Okay, it could be a segment, it could a ray, however you want to indicate it, because I don't know what's happening over here. As long as the limit as x approaches -1 from the left is equal to 0. Done. Okay, you could have this crazy spaghetti wiggly line or curve, because it wouldn't be a line. Okay, so I'm done with this. I'll go back and check it at the end, but I'm done with that part. Okay, now I will move to approaching -1 from the right. Here it says the limit as x approaches -1 from the right-hand side is equal to positive infinity, meaning my graph is going to approach that vertical asymptote and increase without bound. True? Okay, but I also have this weird point in the middle. So maybe consider including that in your graph or whatever you're going to use. So I'm going to, go in this direction like this. Okay? Now, I don't know what's happening right here. I have to keep going. So I've just made this tail off to the left of that point, but coming or heading towards -1 from the right. So check. All right, so now we have the limit as x approaches 1 from the left. So we're coming from this side. That will take care of this part of my graph right here. Okay? It's equal to 1. Okay, meaning if I just continue on with this graph, the limit as x is approaching 1 has to be equal to 1. Can I just put a point right here? Right here? Closed circle? Why open? Why does it have to be open? Yeah, I already have this point right here. So if this point was not here, could I potentially make this closed? Yeah, I could, but in this case, this sort of takes care of it for me. So I have to make this an open circle, and I'm just making it big, exaggerated, and I come from this side just so that you can see it like this. Okay? And then the last part, we are approaching 1 from the right-hand side. Okay, so as our graph is coming from this direction, the limit as x approaches 1 from the right is equal to negative infinity. What is happening? What is the behavior of this part of the graph? Yeah, it's heading down. Does it really matter what it looks like? No. But, I mean, a standard, what you guys are used to seeing might be something like this. Okay, is that boring? Yeah. Is it right? Yeah. So sometimes going with boring is better. Okay, so then it is a good idea to go back and check. So we read this. If I asked you to evaluate the limit as x approaches negative 1 from the left, x approaches negative 1 from the left, it's equal to 0. Check. The limit as x approaches 1 from the right, so I'm coming from this direction, negative 1 from the right, is going to positive infinity. Taken care of, and I'm including this point in my graph that was given to me before. The limit as x approaches positive 1 from the left is equal to 1. Check. And I took care of the fact that 1 point was already accounted for, so now this is an open circle. The limit as x approaches 1 from the right goes to negative infinity. Done. Okay, questions? These take practice. You have to be meticulous and check your work. Okay. No questions. Okay. All right, so what you have now is an activity.